Welcome to this Minecraft seed finding tutorial in Java. I know it's a long tutorial, but it's covering a lot of different examples, so just skip through the timestamp parts of whatever you want to watch. Not all of them are necessary for every program. I just thought they all covered different aspects that are kind of helpful to know. So first I'll be covering just Minecraft world generation basics of like how world generation works and the important parts of how you need to know how it works to code. Then just how to quickly get an IDE working with the seed finding libraries. Then I'll show how to search through random seeds as well as world seeds that you have in a file, for example, like the list of 12i seeds, or just seeds that you already have generated for another reason, and a basic structure finder example, and then looking for close-end cities or fastions, which are fortresses and bastions really close together. So first, for the world generation, there's three real important terms you need to know and just kind of what they do. So the world seed is the actual numbers that you'll know of what you input into the game, which is like what /seed will output in the game. And it's a 64-bit number. And this is the combination of the structure seed and the biome seed. So the structure seed is a 48-bit value that determines what structures go where. And this is how the game knows like what to put where in the earlier stages of generation. And structures spawn like one structure per structure region, and the region sizes vary depending on the structure. Like a woodland mansion would have a very large region, so that's why they're not very common. But something like a ocean ruin would have a very small region. But then the biome seed is the other 16 bits of the world seed that determines the biome variations between the seeds. So the actual like biome generation of like how the world looks is dependent on these 16 bits, and if the structures can spawn into the actual world, which is what most of this tutorial will be covering, is dependent on the biome seed. Because, for example, there's going to be one ocean ruin spawning in every structure region, but in the actual game there are not ocean ruins on land everywhere. So it's only the biome seed will determine if the structures will end up actually spawning in the game. So when you're trying to do seed finding, every structure seed can be combined with 2 to the power of 16 biome seeds. So once you loop through your structure seeds and find one that matches, then you want to check it against the biome seeds to see if what you found in the structure seed will actually end up spawning in the final 64-bit world seed. So those are the basics, and now we'll move on to getting your IDE set up. If you want to code, you want to have a good Java IDE. I use IntelliJ just because tutorial I saw used it, and I think it's very helpful for the libraries. So just search up IntelliJ Community Edition and download the one for your OS. So once you have IntelliJ working, you want to go to File and then New and Project, and then you want to select Groovy. Make sure this Gradle is highlighted, and then go to next, name your project whatever you want, and click finish. But I've already got mine here in the background. Once you've got your IDE working, you want to go to the KaptainWutax seed library and scroll down to the bottom of the README. And you can see here that the like what code you need to add to your Gradle file, your build.gradle file. So this will already be there by default. So you just need to copy this and add it there like it says, and then copy this. And then once you click this elephant icon on the top, it should load the changes and install the library. So like you can see, it is building the project and installing the library. You want to go to Java, right click, and then do new package, and you can name this whatever you want. But the standard form is com dot and then your username, so I'm going to do com.andpenguin. And then you want to create your main class and call it main. So now in here, this is where you're going to be basically just managing all of your seed finding. And for the first example I'm going to show is going to be looking through seeds randomly. So if you just want to find any seed that matches your conditions, do this. And the other option I'll be going through later is going through a list of seeds that you already have to filter them out for like a specific condition. So the filtering will be the same, but the way you look through the seeds is going to be different. So this is going to be looking through a seed randomly. So the first thing you want to do is create your main method. So static void main string. I'm bad. Okay, args. And then, so what I like to do for the filtering is you want to have a method that filters through structure seeds and then biome seeds. So, like I explained earlier, you want to filter through structure seeds to find the seeds that just that might match your structures, and then later you're going to be able to filter through the biome seeds of each of those structure seeds to be able to see if you can get an actual playable seed that matches that. So the way that the code's going to work out, you're going to want to have a method that will have a Boolean return so you can see if the structure seed matches. And then you're going to want the parameters to be the seed and something called a chunk rand, which we'll get to in a second. And you can see that once you've imported the library, it'll highlight this because in IntelliJ it'll show you things from imported libraries. So you can just click on this and it'll import it for you. So once you have that, for now we can just make this return true because we don't really care about. Oh, sorry, you have to name this. We don't really care about what the filter does, though. We'll get to this eventually. But this just checks if the structure seed matches our conditions. And then we'll also want one that will just filter through the biome seed. And you don't need the chunk rand for this just because of the way that the library works. You just need the seed. And for this, we'll say return true. So then what you want to do is you want to have, let's just say, I just like to print out that the program is generating a seed, just so when you're looking at it, you can see that it started. And then what you want to do first is create, if you're doing it randomly, you want to create your chunk rand and your seed. So first let's create the chunk rand, and there is no parameter for this. I'm honestly not too sure what it does specifically, but it helps basically create the structures in the code. So you can just create it like this. Like there's no other parameters required. And then for the seed, if you want to create a new random number, you can just do java.utils random class. So you can just call it random, say numRand equals new random. And then you can have your seed. Actually, let's keep the seed as an instance variable just so we can see it easiest. Yeah. So then you create the seed is dot next long. So when we do it like this, wait, hold on this one. Oh yeah. Yeah, so you want it to be a static variable so that you can just access it, because the main class doesn't have a constructor, so we're just going to call the main method no matter what. So then you just create a random long, but then you want to make it a structure seed, and as we discussed earlier, the structure seed is 48 bits. So what you want to do is you want to make this modulus 1 shifted 48 bits. So this creates a 48-bit long any random thing. So this will create a random 48-bit number that will eventually combine with the biome seed later to get our final world seed. Okay, and then we'll want to loop through the seeds, and we'll look for while the seed is, we'll keep searching until we find a seed that matches. So with this, we can just use a while true loop, and then basically return in the loop so we can break out of it when a seed matches. So no, you just want to use normal logic and do, obviously, if filter structure seed, with your seed that you just randomly generated, and your rand that you generated. Oh yeah, sorry. You want to make everything in this class static. I just am used to writing non-static methods, but you want to create these as static methods so that way you don't have to have a constructor for the main class. So like the instance variables and all the methods, as you can see, are static. So you create the structure seed check. So if this is true, so if the structure seed matches, then you want to loop through every biome seed. Let me just write this down. Then you want to loop through all biome seeds. So like I said earlier, biome seeds in the generation explanation, biome seeds are 16 bits, and we can combine them with the structure seed, which is 48 bits. So you want to loop through all numbers from 0 to the maximum 16-bit number, so that way we can get through all the biome seeds. So to do that, you want to have long biome seed equals 0. Biome seed is less than, and this is a little tricky and unusual, but I just learned that this is the easiest way to do it, is you want to write one long shifted 16 bits. So this is basically the maximum 16-bit number, just like this was the maximum 48-bit number. And then just make this incremental so it goes up by 1 each time. So then you want to see if filter biome seed, and the way that you write the actual biome seed. Now, however, what I need to explain here is that when you filter the biome seed, you're not filtering the 16-bit number. You're actually, like when you're looking for biomes, you're actually filtering the 64-bit number. So even though you're looping through the biome seeds, this is really accurately checking if the total world seed matches, but you're varying it through the biome seeds. So you want to do is create, let's call it world seed, biome seed combined with the structure seed. Yes, you want to move the, so you want to create the biome seed shifted 48 bits combined with the seed. And this is a little weird, but when you do this, it just creates the 64-bit number that we normally know as the world seed, which is the kind of thing that you would just input into a chunk base or your client, and that would actually load up the world. So this is what we're actually checking. So then if you want to see if this is true, then we can know that this this world seed is exactly what we want. So then we can, if we're only looking for one seed, which we are right now, we can just end the program. So we can just be like, we can print out the world seed and be like, is a matching seed. And then we can just return so that this while loop ends and we exit the method. And we should be done with this main method. So this is a pretty simple main method if you just want to loop through seeds randomly and print out the seeds. And while the number shifting is a little complicated and unusual, this is basically the bare bones of everything you'll need for every seed finding program, and you just need to edit what's behind this method and this method. So now, let's go on to the step of creating filters for structures. So now while the main class was more kind of just like weird numbers and just like you have to follow this exact pattern, the structure step is a lot more variable. So I'm going to show you how to filter for basically whatever structure you want. So let's create a class and let's call it structure filter. You can call it whatever you want. You know, something normally ending in filter is kind of more obvious. And then let's give it a constructor. So public structure filter. And then we want the parameter for structure filters to have the seed and the chunk rand, like we had with our filter structure seed method here. So then with this, what we want to do is just save these values as instance variables. We can have private long seed, private chunk rand, and then we can have this dot seed equals seed, this dot rand equals rand. So what this does is it will just save these values into the class, and we'll be able to use them later. So then let's create a method called public and then boolean. Most of the methods in this tutorial will be booleans because we're just checking, all right, does this work, does this work, does this work, does this work? And basically if almost any of them are false, then we want to just go on to the next seed. So we can see public boolean filter seed, call that. And then for this example, let's do, how about filtering for a seed that has a desert pyramid near spawn. So what we want to do is create an instance variable for a desert pyramid. You can make this public. Sometimes it's useful for later steps. Public desert pyramid. You can just call it temple because it's really desert temple, but the library just calls it a desert pyramid. Equals new desert pyramid, and then the parameter for almost all structures is just the version. So we could want to do MC version, and then I'm not sure if it's just because I've used this version before or if this is just the most used version, but it pops up with this one, and 1.16.1 is what I'm going to be using for this example. So you want to do 1.16.1, but you can also do what you can also do that I think is useful is do something like this: public static final MC version. So we're just saving it here, so that way later on we can just use it and just call it version. Now something like ruin portal will have the dimension as a parameter, so if we wanted to create a ruined portal, for example, we would do public ruined portal equals new ruined portal, and then you can see when you hover it over in IntelliJ that the parameters are the dimension and the version. So you would want to do dimension.overworld, but that's just a more of a specific example. And then okay, so dimension specific example, but I won't be using this one for this example. And then desert pyramid template basically. And then this is just the same stuff as the main class. So yeah, this is all the instance variables we're going to have for now. So then to actually filter out a seed. So what you want to do, for example, if we're going to check if this has, let's say, desert temple within 100 blocks of spawn. So then let's say we create a variable that's like, let's just make an instance variable just in case we want to use it somewhere else. Public static double max dist. And we want to have this as a double just so we can be more precise. And we also want to have it as a final because we're not going to change this anywhere else, and it's just like a set value. Now, the thing with the max distance that's kind of counterintuitive is that you want to have it as the square of the actual value you want. So we want to have it as the square of 100. Now, this is because apparently the way the math works out is that when you're calculating the distance, it uses the distance squared between two places. And when we have the distance squared, we want to have you don't want to have to square root it and then use the double max distance, so you can just use the squared max distance. And you'll see what this means in just a second here. So what we want to do is create the like basically find where a desert temple is in a certain region on the seed. So like I explained in the terrain generation explanation, is that on structure seeds there's like regions of varying sizes for each structure, but basically like around 0, there will be like 4 regions. And you might know this from bastions and fortresses about like neg pause and whatever, but you know, like all structures spawn the same way. So we can look for a desert temple in the 0 region. So the 0 region is pause because it's just 0 based, so it'll be like 0 over here, and then neg 1 over here, and those are your 4 regions. So when we do that, we want to create a variable of the type cpos, which stands for chunk position. So we'll get the chunk position of where the temple is. And to find this position, it's not too complicated, so we'll call it first like temple loc, which is just like temple location, equals the temple. So when you create this temple template, that's a funny name, temple template, then you can just do temple.get in region. Makes sense because we're finding where it is in this region. And you can see that the parameters for this are the structure seed, the X region, which is going to be 0, the Z region is going to be 0, and chunk ran that we have. So we just have to fill all this in. So it's just seed 0, 0, rand. And this will give us the chunk position of where this temple is. So then we want to see, alright, is that chunk position actually within 100 blocks of 0, 0? And the way you do this is, we'll just make it a return statement because we want to see if it is or not. And then that's what we're going to return. Return dot distance to. So we have this chunk position, and we can do the distance to another chunk position. And the other chunk position we're going to have is 0, 0. So the way we can do that is so the way you want to do this is you want to get the distance to 0, 0. Now, when you're doing a distance to any point, you can use the method distance to, and you can basically get to another chunk position. So we like create a chunk position 0, 0. And then we could use this distance metric, which is basically just like how we're going to measure it, and this ties back to the squared thing of, and the distance metric that we would use to measure is this Euclidean squared. So it basically just finds the distance squared, so it doesn't have to square root it, and then we would compare it to this constant that's squared. So you can do this and see if it is greater than or see if it's less than or equal to, or see if it's less than our max distance. So this is one option that works better for just like generically, like at any chunk position. So Oh, excellent, dragon. Okay. Works for any chunk position. So if you just wanted a chunk position that's here, so like, you could want to see if a temple is within a certain distance of, I don't know, like a ruined portal, like, if you want to spawn like that, like I've used before. But if you just want to see if it's from 0, 0, there's a little bit of a shortcut method that you can use. So we can just get rid of that, and then we can do return temple lock dot get magnitude squared. So this method basically just does this, but it's, obviously a lot smaller. And then you can just do less than max distance. So this is obviously a Boolean because it's checking if it's less than that, and if it is, it'll return true. So now we just have to call this method. So you can see this is really simple. It's just 2 lines just to find if there is a temple next to 0, 0. And if we wanted to do that, we would just do, let's create a new, let's see, structure filter object that we named over there. And then we have to initialize it with the seed and rand that was passed into this method. And then we want to call the method filter seed. So if this returns true, then this method will return true. And then we'll just leave the filter biome seed alone for now and just assume that it passes. While we're at it, just so we can see what this output will look like, let's print out the temple location. So this will print out the chunk coordinates of the temple. And while it's most likely that with just the structure seed, it won't actually be a temple because the region won't be a desert. And in the game, when it's generating later, it's like, oh, we can't spawn a temple here. This is a plains biome. But it will give us a structure seed where the temple will work, and it will combine it with this with the biome seed 0, and it will give us that seed. So now, if you just want to run a program, you just go to your main class and you click on the green arrow next to the main method, so that'll run the main.main. So hopefully if everything works out, it should print out a seed that has a temple at the 0, 0 location. So first it has to actually like retrieve the data because it's building the project for the first time. And now we've seen that it generates a seed, and then it gets one that has a temple at the chunk coordinates 12, 23. Okay, now I made a silly mistake, and I think this is a good example of debugging. So what you really, the issue with this is that this is checking if and this is like something that can happen, I think it's good that they're explaining it, is that the temple's location right now is in chunk form. So this is checking if the temple's chunk coordinates magnitude is less than 100 chunks. And this is obviously less than 100 chunks away. I'm pretty sure any temple is going to be less than 100 chunks away. So what you really need to do is do temple location dot to block position, and you're going to do this with almost every structure. If you want your distance variable in blocks, but sometimes you will actually have your distance variable in chunks, like I've used previously for finding a fashion. I've had it in chunks. It's just easier that way, and then you don't have to have this. But anytime that you're using in block position. Okay, and then the other fix for this program is to prevent it from printing out the temple's location every time. We only want to print it out if the magnitude is actually less than 100, so we can see where it is. We'll just change this return to an if statement. Keep this second. Nice. So if it's like that, then print this out. And we'll also convert it to the block position just so we can see the exact location of the temple. And then we also need to add the return statements. So, like if it does have this, return true. If it doesn't, return false. So now we can see that this temple is at 80 and 48, and these numbers are divisible by 16 because it literally converts the block position. So it's only precise to a block, as far as I can tell. You might be, or as far to a chunk. I think it might be possible to get the block position of a temple, but I mean, it's like accurate enough that you'll be able to get it within 16 blocks. So basically just like plus or minus 8. So it's at this position, which is less than 100. Now, but it's probably not a desert. So the next step that we're going to do is finding if the structures that we have are actually there in that biome. Structure is actually on the seed is to finding if there is on that biome seed with the biome filter class that I'm going to create. So create a class, call it biome filter, and then give it a constructor and an instance variable like we did with the other one. Biome filter long seed, but notice how this has no chunk rand because in the main we don't need a chunk rand for this method here, so this class will not have a chunk rand. And then we'll just do this dot seed equals seed. And then we just need to create a method to actually filter the biome seed. So it'll return a boolean if it's if the seed matches or not. Filter biome seed. Actually, we can just call it filter seed just to be the inconsistency with the other one. So then what you want to do is now that we have this method, we can just call it return true for now, just to avoid errors. And the thing is with filtering a structure seed and a biome seed at the same time is that you need to save this data of where the temple is. So that way on the biome seed we can see that if it's actually there at that position. So the way I do this is I just create basically just a data storage class, and like I just said, I call it storage, and then we can just store a couple of chunk positions in here. Right now we just need the one, and we'll call it public chunk position temple chords. So now we can go back to the structure filter, and the only thing we should need to change is when this is checked, just do temple location. We add storage dot temple chords equals temple lock. So now we just have this saved. Oh yeah, you also need to make all the methods in this static because we're gonna just have one set of this. If I can type. Okay, yeah. So we just have static temple chords. So now, once we find a valuable temple in the structure filter, it'll get saved into here so that we can use it later for the biome filter. So now, in the filter seed, you just want to do the one method that we're basically going to use is called can spawn, and we want to use it on the pyramid template that we created in the structure filter up here. So we just need to go if structure dot pyramid. Oh, we need to make this. Yeah, I think the lesson you're learning here is that I need to make my variables static more often than not, and I'm forgetting it. So yeah, if structure filter dot pyramid or temple, sorry, dot can spawn. So like I said, can spawn. You want to use this one, the chunk position biome source, and then the chunk position we're gonna have is storage dot temple chords. So that's the data we just saved. and then the one thing, and then the source is going to be an overworld biome source. Let's just call this up here just so it's cleaner. And then the parameter for this is just the seed and the version. So like I said, how we're going to use this later on, we can just call structure filter.version. So yeah, oh, is it the other way around? Okay, yeah, it's the other way around. Yeah, so now we have our overall biome source, which basically just helps us see what biomes are where. So then if the temple can spawn at the coordinates we got with that biome source of the seed, then we can just return true. Otherwise, return false. Now, assuming I'm not forgetting anything, that should be it. And you can just run the main method again. There should be a green arrow once you've run the main method, so it'll run the same thing again. Okay. So before you run the code to make sure that it's working, there's a couple of things that we need to change in the main class. So firstly, we basically just need to copy this so that way we can generate a different structure seed each time. So if the structure seed doesn't match and the biome seed doesn't match, so the program doesn't just end, then we want to test it with another different structure seed. So we'll just copy this and put it back down there. And then the other thing we need to do is actually use the new biome filter code that we created. So we just want to do the same thing we did over here, but we want to use a biome filter instead of a structure filter, and just use the seed parameter because that's what we called it. So now, we're filtering the structure seed and the biome seed. So now you see we've gotten a temple that has that's within 100 blocks on a structure seed, but we need to find a biome seed where it's on an actual desert. So now we can see that it's taking a long time and it still hasn't generated a seed. And this is because there's an issue with just the way, or maybe it's not an issue, maybe it's a feature with the way that Minecraft works, in that certain structure seeds basically never contain the right biomes. So what you want to do is after you've checked like 100 structure seeds to see if it is a desert at spawn and the temple can spawn, you want to just skip it. Because there's 2 to the power of 16 different structure seeds, but once you get past like 100, you know there's not going to be any good ones. So the easiest way to do this is to do if biome seed is greater than 100, or sorry, actually, yeah, the easiest way to do this is just to make this go from 0 to 100. Now I showed 1 to 2 to the power of 16 earlier, just to show like what the normal range is, because sometimes you want to change this after instead of in the for loop, but because we only have one thing we're filtering out, and we know that it's probably going to be from 0 to 100 seeds, we can just redo this, checking that. So now you can see it was much faster because it went through all of these and was like, no, no desert, no desert, no desert. And then it was like, all right, there is actually desert on this one. So now if we go over to chunk base, at spawn, within 100 blocks of 0, 0, there is indeed a desert temple. So yay, first successful seed finding endeavor. This is instead of just going through random structure seeds like this, is you can look through a list of world seeds through a file. So for example, I just generated a lot of world seeds from the desert temple filter that we just created, and now I'll be able to look for those seeds through a file using another method. So it's just a slight variation off this main method. So just to get rid of this, I'll just rename it, and then we can create another actual main method. So public void, public static, void main string args. And then you want to have basically the same thing, but some changes you need to make. Instead of a seed here, you want a scanner. So a scanner is the easiest way to read through a file in Java. So you can create scanner, scanner equals new scanner, and then a scanner takes a file in as an input, and the file here is seeds.txt in the just like the root of the demo. So you want to do dot slash because that goes to the root, and then seeds.txt. Okay, but this is a new file. Yeah. But the issue with scanners is that you need to put it in a try in case there's no actual file, like it doesn't find the file, so that way the program doesn't crash. And we can just print out the error just in case it happens. And then we just have to change the true to scanner has next long, because this is just while the scanner keeps on having. Oh, we have to move this while loop inside of the try so that way it has scope. So while the scanner has another seed in it, then we're just gonna have to define our seed. And the seed, it's pretty similar to this one, but instead it's gonna be scanner.nextLong. Mod 1L shifted 48 bits. So this is basically converting the world seed to a structure seed. So just like how we generated basically a random 64-bit long here and converted it to a 48-bit, we're getting the known 64-bit number from the file here and converting it to a 48-bit structure seed. So that way we can check if that structure seed is valid of the world seed. So we check if the structure seed's valid, then we just loop through the biome seeds again, get the world seed, check if the biome seed, or check if the world seed at that biome seed is valid, and then print it out. And this can just be deleted. And the random there can be deleted, and that should be it. So we can see that here it's printing out all the seeds in the file, and if you wanted to just do one, then you'll just put return like I had up here. Oh wait, oh sorry, I deleted the return to generate all the seeds, but yeah, you just want to have a return if you want to just get one seed. So now, yeah, we just printed out the first seed in the file, like you can see. I'll just write what this does, and we'll be done with that method. Is finding an end city, because there is a very specific way to do it, and it's pretty useful to know for a lot of different examples. So the first things you want to do is define an end city like we've done up here. So we have public static end city, or we'll call it end city equals new end city version. And then you also need to create an instance variable to save the location of the city, so that way we can use it in other methods. Alright, so then the first thing you need to do is put in this method that will be available online, just because it's a very specific way to calculate the location of the first gateway that spawns after you kill the dragon. It's kind of complex, but it just basically uses trig to find the location of where the gateway will spawn based on the seed, because there's 20 gateways and it needs to find which one is going to be the first one and where the exact coordinates are going to be in the outer end islands. So once it does that, once you have that in, then you can continue with the methods. So then we have to filter the end, so we call it filter end. Find if there is a close end city structure. And then we just have to find, basically you have to call the first gateway method. So you have, and then you have to basically convert this to a region position, so that way you can find the region the gateway is in relative to the end city, so that way you can find an end city that's in a region very close to that. So you just do rpos, which is basically the region position, like bpos block position, cpos is chunk position, rpos is region position. Region equals gateway dot to region position, and then you want to convert the region size is 20 shifted to 4, and then now that we have the region, we can get the end city in that region. So end city dot get in region. Okay, and this returns, so we want to save this city here to be at that region, so that way we can use this later. So we want to save city is end city get in the region of the regions X, the regions Z, and then we also need to add the rand and the C. So now we have the city's coordinates stored, and all we need to do now is just return if the city is actually close to the gateway. So return city dot distance to, or city dot to block position dot distance to the gateway, and then we want to use the Euclidean squared metric, and we can use our, well, let's say we can use our 100 block max distance that we defined up here. So now this will return if the city's block position is within 100 blocks of the actual gateway. So now that we have that, we need to check if the city will actually spawn, and if it will actually spawn with a ship. So we need to basically just filter the end city biomes, because the city won't be able to spawn if it just spawns over like void or wherever. But most of this is just for checking if it actually spawns within a Elytra ship. So we'll call this public boolean filter end biomes. And we first need to get define two classes that will help us see what the biomes are. So the first is end biome source. And then end terrain generator. And this just takes the this just takes the well, let me highlight this for some reason. Okay, we'll just takes the source as the parameter. So then once you have that, we have to just check if the end city can't spawn, and that's end city dot can spawn, and that's why we save this chunk position. So city dot get x, city dot get z, source. And we just want to return false because the city can't actually be there. And then if it can't generate then we also just want to return false. But instead of source, we want to use the generator. Okay. And then we want to check if the end city has a ship. Yeah, and then to see if it has a ship, we have to define an end city generator. And then we just have to generate the end city. Call it with the terrain generator and the city chunk coordinates. So then if generator dot has ship, we can just return that. So now I haven't fully checked this, but if we go back to our main and then we change the biome seed to not matter, we just return true. And then we change this to structure filter dot filter end. Well, the thing is though, if you're calling two methods with it, you probably want to do structure filter equals new structure filter, and then you want to call filter return filter dot filter end and filter dot filter end biomes. So now if we loop through this, I'll just change this back to our original looking for a seed randomly. We should be able to find a seed that has a close ending. So yeah, this says that this is a matching seed. We can try and check it on chunk base, but the issue with that is that on chunk base, you can't see where the first gateway is going to spawn because it doesn't spawn with the world. It spawns once you kill the dragon. But we should be able to see a seed with a ship like close to the edge of the outer end islands. So yeah, it could be this one, but it could also be this city or this city if that's where the gateway spawns. I'm not too sure. We have to go load up the world and check, but I'm pretty sure that this example is working. So that's how you find it. Example to do is finding Fastions, which are fortresses and bastions very close together. So to start this off, we'll just want to go to the storage class and save the location of our bastion, because we'll need to look at it later to see if it got covered up by basalt or not. Then we can just go to the structure filter class and create a filter nether method. And this will just look for fashion. And then we'll also just create a distance for how close we want our fashions to be. What I like to do is just have them within 10 chunks of 0, 0, and then also 10 chunks of each other. So we can call it nether dist. And then we'll do 10 times 10. And this is in chunk. We'll keep this as a chunk distance. So in chunks. But this is in blocks. So then when you want to do this, your first thing you have to do is just reset the bastion coords to null. So that way you're not reusing any coordinates from the previous structure seeds. So then what you need to do is loop through the primary quadrants. So that's like pause, 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 neg, neg, pause, and neg, neg, which is where the bastions and fortresses are going to be closest to spawn. So to do this, we want to loop through the X regions. So you can see this goes from -1 and to 0 and then stops. And then we also want to have a nested loop going through the Z regions. Now I need to call this string. Yeah, but then we want to also create an array to store the locations of the bastions and fortresses. So we'll do cpos array FastionWutax equals to cpos 4, and then we'll do the same thing with fortresses. So that way we can just store them when we go through this array. So now when you want to have an array which starts at 0 and goes up to 3 because it's 0-based counting, so the array positions will go 0, 1, 2, and 3, but the quadrants are -1 and -1. The way that you want to store the data is doing something like this. So you'll have fashion locations at the index of x plus 1 plus z plus 1 times 2 is equal to, oh yeah, we'll define a fortress and bastion. So yeah, so then we'll just do get in region like we've done previously, equals bastion dot get in region seed x z rand, and then we'll just do the same thing with fortress locations. So this will make it so that if you are at -1, -1, it'll save it at the 0 index of the array. So yeah, now we have all of our locations saved, and now we need to check if they are close to each other, if fastions are present. So now for fastions, there's two things. We want them to be close to 0, 0 and close to each other. So then once again, we want to loop. This time we want to loop through each fortress location and check if there's a bastion that's close to it. So for cpos fortress logs, for bastion logs, or for, and then loop through each of the bastions. Then we just need to check, alright, are they close to each other? So if bastion dot get magnitude squared, or if fortress dot get magnitude squared is less than nether distance, and then we'll just continue this on the other line. Let's see. And then and fortress dot distance to the bastion is less than nether distance. Oh yeah, and you also need to use the distance metric here because it's distance to and not get magnitude squared. Oh, I wrote and twice. Yeah. So if that is true, then we want to save the bastion location equals bastion. So fashion found. And then we can just return true. But if we go through all of these loops and check that none of them are close enough to each other, then we return false. And then the last thing we need to do is just check if the biomes are close enough to each other, if the biomes work for the Bastion. So public boolean filter nether biomes. And then you just do return storage dot bastion, or return bastion dot can spawn, and then we want to use the bastion coords that we saved, and then the terrain generator, or the biome generator. So yeah, if it can spawn because the biome works, then it should work. Oh wait, this is still going to be running the end city here. So then if we change this to be doing filter nether, and this does filter nether biomes, then this should work. Oh yeah, so you do have to check in the structure filter if the fortress or bastion are null. So if there is an actual fortress or bastion in the quadrant, then you want to not try and call stuff with it. So so yeah, now we got this seed. It should hopefully have a fashion. And then we just show 0, 0. We can see that there is indeed a housing fashion pretty close to spawn, and these two are very close. I'm going to be making a tutorial on finding seeds based on biomes instead of structures, using topics like biome shortcutting to speed up finding rare biomes. And if you have any questions or feedback, just leave it in the comments, and or just ask me on Discord and I'll be happy to answer.